James Webb Space Telescope launched in 2021, been observing the dark regions of the universe, not only seeking clues to how the early universe formed, also analyzing the atmospheres of nearby exoplanets, looking for biologically produced gases. Life is also known as biological characteristics and advanced alien civilizations. Possible chemical substances become a technical feature where researchers have not yet fully identified the telescope. Is it really possible to achieve these heavy, big technical feats? So just recently, they decided to test James Webb Space Telescope, see if he can successfully detect livable from the only known and intelligent life on inhabited planets. In a brand new study, researchers have obtained a spectrum of the Earth's atmosphere and deliberately downplayed the data, make it appear as if the telescope is moving from many light years, looking beyond the Earth's atmosphere. Then they created a computer model of the function of the sensor to see if he can detect it. Life on Earth, methane produced by life, and key biological characteristics such as oxygen, and technical characteristics such as nitrogen dioxide and chlorofluorohydrophilus. The results were surprising. The research team found that modified dataset equivalent to the James Webb Space Telescope from TRAPPIST, which is about 40 light years from Earth, observing the Earth from a star system. That is to say, the telescope should be able to reach this range. Life detected or alien civilizations. But the impact of exciting new discoveries may prove if the telescope spans the galaxy, it can also see life on another planet. The 8 recently detected planets of K2O, about 120 light years from the solar system. This exoplanet is 8.6 times the mass of Earth. It is about 2 to 3 times the size of the Earth. It's a Heason world. This means his atmosphere may contain abundant hydrogen, and it has oceans of liquid water on its surface. While studying the atmosphere of K28b, JWST detected carbon dioxide and methane. It's already exciting, but that was not the finding. Fascinating reason. 2. Methylenes are molecules that vent on Earth. It could also exist on this alien world. DNS is particularly interesting because on our planet, it's produced as a byproduct of life. On Earth, it is usually composed of a tiny plant-like. Organisms are produced in the marine environment. This makes DMS a potential solution. The biological characteristics of that was before never detected on its exoplanets. In the past, when astronomers searched for signs of life, mainly consider rocky planets. However, the seaweed world is a kind of hot, a planet covered in water, more suitable for atmospheric observation, now considered more likely to be extraterrestrial, candidate for life. This is also because most exoplanets that have been invented completely different from Earth. Therefore, they may be extremely rare. Scientists have not yet determined K28-1. Does it contain dimethyl? James Webb Space Telescope. There's almost no time to observe this sucking behavior. Therefore, we need more data to confirm these findings. In the near future, we will find out if the K28 is better than. Is there a large amount of DMS? However, even so, we also can't be sure that on this seaweed planet, does life exist? Due to various reasons, observing biometrics is tricky. We are mainly based on our understanding of the Earth, environmental understanding to study. Their other problem is, biological characteristics can have multiple origins. It's not just about the organism. Take oxygen, although it is past photosynthesis of plants and algae on Earth produced, but it can also be purely geological or abiotic process. For example, the breakdown of oxygenated minerals, or the result of a chemical reaction involving a negative oxygen compound. It is certain that we are making progress. At first, our focus was on finding planets similar in size to Earth. Then we expanded the criteria, include a district in it, concerned about the existence of liquid water. Now we are updating in-depth study of the chemical composition of the exoplanet. Even at this stage of technological progress, we have been able to pass so-called atmospheric optics to search for the biological signatures of alien worlds. All the time, scientists are searching for detection planets, new methods for biomarkers. Some of these methods can even be described about the extraterrestrials that exist there, the appearance of life forms. In one study, scientists have studied the early days of life on Earth. It was home to a variety of early life forms, such as purple bacteria. They built several models to identify such cases. Will the widespread existence of organisms affect the Earth? The way you see it from a distance, simulation involves different variables, such as the demeanor and distribution of bacteria, including aquatic and terrestrial environments, and the presence and density of clouds in the atmosphere at the time of observation. The research findings are exciting. Purple bacteria have a unique way of reflecting light, make them within a certain color range stand out. This is similar to the red edge observed in leafy greens. Phenomenon is similar. The reflectivity of green vegetation in the near-infrared range. Sharp increase, but for the purple bacteria, this increase occurs in slightly different color range. This unique feature is due to special pigment and light absorption properties of bacteria. It helps them capture and utilize light to meet their energy needs. Now, given the land area of the outside world, domains are abundant in purple bacteria, and the sky is not significantly clouded. We might be able to use specific optics. The filter detects the presence of such organisms. James Webb Space Telescope recently. Indeed, many exciting new discoveries have been made, but they are not the telescope this year's only discovery. The next discovery generated a lot of debate and controversy. Our universe is expanding. The attractive force pulls all matter together. Past physicists believe this expansion will eventually slow down, but then we found out the expansion of the universe is actually accelerating. If we only consider ordinary matter, it doesn't make sense. So there must be other factors at play. That's when scientists have considered the universe to elusive entities that are ubiquitous. The existence of dark matter and dark energy. Dark matter is like an invisible substance in space, can help galaxies and galaxy clusters stick together. It's 27% of the universe, like a hidden framework, fix everything in place. Although it does not interact with ordinary matter, it doesn't shine, but can still be studied according to its attractive force. Pressing energy is another puzzling phenomenon. It makes up about 68% of the universe. Is the driving force behind the accelerating expansion of the universe? By examining the patterns and motions of the stars, we can tell how many of them there are, although we can't see or touch it. But scientists know it exists because of their understanding of the cosmic background, radiation, and the overall structure of the universe. Made careful measurements. Until recently, astrophysicists have no evidence yet, certificate material, or the existence of dark energy, but that may have just changed. The core of a star. It works through a process called nuclear fusion. Nuclear fusion refers to lighter elements, such as Ching fuses together to produce heavier elements, mainly harm. This transformation unleashes amazing energy. It radiates out in the form of light and heat. This keeps the star out in the vastness of space. Sparkle. But there could be another way. Powering stars. Dark matter to be precise, or the heat released when itself drowns. The SCARF telescope can observe some of the universe, the most remote region, basically looking back. Due to the early universe, very different from today's universe, when truly bizarre celestial bodies were formed. For example, stars more massive than those formed today, stars thousands of times larger. they discovered for stars, JWST-12 and JWST-13 are so far observed one of the most distant celestial bodies. According to astrophysicists, JWST 11, 12, and 13 could be powered by dark matter, make them theoretical dark stars. Although they are called dark stars, but they still shine. Maybe 1 billion times the Sun. The mass is also millions of times larger. Scientists believe that shortly after the Big Bang, dark stars are full of harm and blue clouds are collapsing. The regions of dark matter that are produced are formed. In physics, there is a theory called supersymmetry. It could explain the formation of such stars. Think of the early universe as a cosmic kitchen. Dark stars are born here when the ingredients from the Big Bang, when Ham and King Yun gathered together, the stars began to cook. Now, if the particles of matter hover, it's called supersymmetry. Then they could act like cosmic twins. Have your own super partner. Every time these particles collide, they will disappear, release a burst of energy, like matter and antimatter drowning. This energy then leads to the formation of other particles, such as photonic government electricity, subteams and neutrinos. Due to neutrinos, hardly interacts with anything, so they escape the clouds. But the remaining components stay inside and interact with each other. They collide with the king sea in the clouds to transfer energy. This energy transfer heats up clouds. It triggers the formation of darkness. Due to these constant, stars don't look like fusion-powered stars, emit high-energy light, so they stay cool longer. It gets bigger. Final dark. The surface temperature of the star may reach the level of the Sun, but it's 1 billion times brighter. This star has a radius of up to 10 astronomical units. No core, and like a star composed of entire ordinary stars, as bright as the line. About 200 million years after the Big Bang, the baby galaxy appeared. Their ingredients are unique, mainly composed of dark matter. These special conditions can only occur early period in the universe. There are no heavy elements, only basic elements such as C and hydrogen. Therefore, dark stars can only be found at the beginning of cosmic history, formed in these early galaxies. This may be something we couldn't see before. The reason observed: technological progress. It's not enough for us to sleep that long. But now we have the scarf telescope. Things started to change dramatically. So, how do telescopes detect these objects when a massive galaxy, from distant stars or galaxies, when the interface passes, its attractive force field bends the path of light? This phenomenon is called attractive force lensing. This effect will not change to distant objects, level 10 physical distance, but it distorts and amplifies the light emitted by these objects. This allows the telescope to enhance its brightness, observing distant celestial bodies, make them appear as if they are being enlarged or enlarged, close to our line of sight, but due to the unimaginable distance involved. Identify these objects as new stars powered by dark matter. Need more time. JS13 is considered a galaxy, but according to computer simulations, 3 of the 4 celestial bodies detected. Maybe it's fake. Dark star set. If true, their discovery will be revolutionary and provide answers to 3 important cosmic puzzles. Previously, James Webb Space Telescope unexpectedly discovered a large number of distant galaxies. These galaxies are significant for the age of the early universe. It's too big. This contradicts our standard cosmological model. According to this model, smaller galaxies formed first, and it grows over time. Therefore, if some of these galaxies end up as dark stars, they will be caused by dark matter. The energy generated by the interaction grows rapidly, so that they can achieve supermass as early as possible. This might help explain why did the early universe there are so many planets. Final probe, Suo's large dark star. Maybe explains the supermassive black holes of the early universe. It's too big, impossible early in the history of the universe. Common rampage. And then there's the nature of dark matter. The existence of dark stars will confirm the existence of solid dark matter particles and prove to us these particles can interact in ways that transcend gravity with the help of attractive force lenses. SCARF telescope. It was also able to detect two other interesting stars, Mothra and Godzilla. The two stars are more than 10 billion light years from Earth and more than expected. Such a bright star is called a monster star. Extremely rare. Mothra is a double supergiant system. The brightness of one of the supergiants, that's 50,000 times the Sun. The temperature is about 5,000 open years. And the other one, the star is 125,000 times brighter than the Sun. The temperature is about 14,000 Kelvin high. Godzilla is considered to be the brightest star ever discovered in the universe. The problem is constant. The luminosity of the star is much greater than that of the Earth, and the magnification of the galaxy cluster between the stars. The scientists were absent. There was something else there, something closer to the star. Whatever this thing is, it's about 10,000 to 2.50 million times the mass of the Sun. And it can't be another star or cluster, as seen through the SCARF telescope. Objects or structures that provide additional magnification. It would be invisible to a telescope, so it could be a black hole, or high concentrations of dark matter, like a dwarf made almost entirely of it. Galaxy. Another hint of dark matter.